All right, so I'm going to go over some of the odd problems from this homework assignment. Remember, this is not meant to be the lecture. You want to make sure you watch the lecture videos first. This is just more of a answer key and a really short process on how to get those answers. So the first thing you notice, and I almost missed it, is there's a greatest common factor among all four terms. Before you do anything else, you need to take out the greatest common factor in this problem, which is 3. So we're dividing all four of those terms by 3. So this is what I'm doing to get the terms remaining on the inside of the parentheses. Now what I'm going to do is I'm going to draw my answer box right here. I'm going to go and put that greatest common factor of 3 on the inside of that answer box, because then I'm going to forget about that 3. And now I'll notice, and this should be a plus, Now I'm going to notice there's 4 terms. So I'm going to put the first 2 terms, I'm going to factor this by grouping. So I'm going to put the first 2 terms in a group. Those first 2 terms have a GCF of x squared. Basically, again, we're dividing the first and second term by that GCF. That gives us x minus 2. And then in that second group, they don't have anything in common, but we can always take out a 1, or in this case, we can take out a -1, since that lead coefficient is negative. So now our factors, what they have in common is one of my factors. And then what's on the outside in front of the factors is my other. Now you should notice x squared minus 1 can be factored again using perfect squares. So the factors of x squared minus 1, square root of x squared is x. The square root of 1 is 1. When you're factoring perfect squares, 1 is always positive, 1 is always negative. And I'm going to bring down my x minus 2. And I'm going to write all my factors together, including that 3. The reason that I like to put the 3 in the answer box right away is because people tend to forget that it was a factor in the first place. All right, so the next problem is a trinomial, x to the 4th plus 11x squared plus 28. There is no greatest common factor on this problem. So we're going to factor this using whatever trinomial method you like best. So box method may have been taught. I think I typically use grouping method. They're all very similar. They all start by multiplying the a value times the c value. So we're looking for 2 numbers that multiply together to give us 28 and add together to give us the b value, which is 11. Those 2 numbers are 7 and 4. 7 plus 4 is 11. 7 times 4 is 28. So I'm going to rewrite the original problem. Instead of 11x squared, I'm going to write it as 7x squared plus 4x squared. Everything else stays the same. Then I'm going to put the first 2 terms in a group and take the GCF of the first 2 terms. That, of course, is x squared. And that leaves us with x squared plus 7. Then we look at that second group. The lead number is positive, so we're going to take out a positive, in this case 4. Good news here is we are done once we write our factors out. X squared plus 7 is half our answer. 7 is not a perfect square. And then x squared plus 4 gives me my other factor. Remember, you can only factor a difference of perfect squares. So x squared and 4 are perfect squares, but it is not a difference problem, so that cannot be factored any further. So that's it. This next problem is going to follow a very similar path as the previous problem. We're looking for factors of negative 36. It's a times c that add together to give us b, negative 5. If you came up with negative 9 and positive 4, you are correct. So I'm going to rewrite negative 5 as negative 9x squared plus 4x squared. Remember, those terms can be switched. You can write the positive 4x squared first if you want. It's not going to matter for your final answer. Put the first two terms in a group. GCF of the first two terms is x squared. Factor out an x squared, you're left with x squared minus 9, which is difference of perfect squares. That tells me we've got a little bit more work to do. The second group, we can factor out a positive 4. And likewise, we're left with x squared minus 9. So our factors are what they have in common. And then what they don't have in common. Remember, only one of these can be factored further. X squared plus 4, because of that plus sign, cannot be factored again. But x squared minus 9 can be factored again. That is a difference of two perfect squares. Square root of x squared is x. The square root of 9 is 3. One is always positive. One is always negative. Doesn't matter which one. All right, and then finally, the last problem. So we've got an x to the 6th problem here. We look and see no GCF. There's 3 terms, so this tells me we're going to use some form of A times C method, whether it's box or whether it's this group I'm showing here. We're looking for factors of negative 42 that add together to give us B value, which in this case is negative 1. So negative 7 and 6 are the two numbers. Notice we're keeping the x to the 3rd exponent in the middle. So it's a negative 7 x to the 3rd plus 6 x to the 3rd minus 21. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . First two terms in a group, the GCF is positive 2, and they both have at least an x to the third in common. Oh, hold 1 second. That's not right. 2 does not go into 7. So I can just take out an x to the third. Remember, we're dividing these two terms by x to the third to see what's left over. So that's going to be 2. When you divide variables, you subtract the exponents. When we take that second group, the GCF of that second group is positive 3. So our factors are what they have in common. And what they don't have in common. Now you gotta ask yourself, do we have, well, we definitely don't have perfect squares here. So that's as far as we can go.